Let's look at an example application of KCL and KVL. In this circuit, the current I1 here is provided to us, and we are being asked what I2 is. We begin by labeling all the nodes A, B, and C. We know the current here in this branch in this direction is 1.5 amps from the definition of this current source. I can now write a KCL at node B, which is sum of currents going into B should be 0. So 1.5 amps is going in here like this. From bottom to top, there is minus I1 current going in. From right to left, there is minus I2 current going in, which gives us this equation. What is given to us in the question is that I1 is 1.2 amps. And if you substitute this information in equation 1, we get the value for I2 as 0.3 amps. Let's look at another example. Here the question is, write down all the equations to solve the circuit. Solving the circuit means we want to find out the currents in all the branches. We begin by labeling the nodes A, B, C, and D. Then I will label the currents I1, I2, and I3 as shown. Note that if I calculate I1, I2, and I3, I know the currents in all the branches. We can now write a KCL equation at B, which will be I1 plus I2 plus I3 equal to 0. These are all the currents going into node B. I can now write a KVL in this left loop clockwise, which will be VD minus VB plus VB minus VA plus VA minus VD, which should be equal to 0. Pause here and convince yourself that this left-hand side of the equation is indeed equal to 0. According to the definition of V1, this voltage source, VD minus VB will be equal to minus V1. Using Ohm's law, VB minus VA, this term, should be a current from B to A, which will be minus I3 times the resistance R2. Similarly, using Ohm's law, VA minus VD will be the current from A to D, which is I1 times R1. So, and this should be equal to 0. This will be our equation 2. Note that I have three variables, I1, I2, I3, which I have to calculate, and I have two equations. That means I need one more equation to solve the circuit. From the definition of this current source I1, I2 should be equal to capital I1, which is our equation 3. Now I have three equations, three variables, which I can use to completely solve the circuit.